Alright, so let's get started. So in the next around 40 minutes, I'd like to give you a brief introduction about a little bit more of the advanced side of TypeScript. So really brief introduction about me. My name is Christian. I've been working in the industry as an engineer for the last 12 years. Started as a Java engineer back then, and then 7 years ago when Angular 2 was released, started also using Angular and TypeScript. So I've been using TypeScript for the last 7 years, doing also some trainings, doing some conference talks. So if you do want to see the code I will show you today, you can scan this QR code, but it will also be available during my talk. So then you can just go to my website. You can then find my GitHub, my LinkedIn, and my mail. If you have any questions later, just send me a mail on or something on LinkedIn. If you have questions, maybe we are a little bit short in time, so you can just scan this QR code or go to type.rocks/QA. You then find there like a Q&A page where you can ask your question. And if you have enough time at the end, I will answer them right away. If not, I will answer them after the talk, and you can then just come back later and see the answers to your questions. All right, already enough with the presentation. Let's go in the code. So the first thing I'd like to show you is about mapped types. So let's say we have a type events here. And this type has two properties, an add property and a remove property. Now what we'd like to do is, let's say we want to have an object, user actions here. And this is of type onEvents. So basically what we want to have an onAdd, which is just a function which basically does some stuff, and onRemove here, which also does other stuff. Now we have to create this onEvents type, right? So what we could do is we can do this manually. We can say, okay, I have this onAdd, which is a function, and this onRemove, which is also a function like this. So this now compiles. But the problem here is that if we are here, if we add another property here, like move, then we will not get a compile time error because these two types are completely separate from each other. So, but what we really like to do is we would like to create a mapped type. So the first thing we do is let's think about how our map type should look like. Basically, it should be like the properties of this events, but with an on prefix and an uppercase letter of this property here. So the first thing we do is we create a type, let's call this event key, and we say everything which this key allows is a key of event. So what you now can do is, if you have an invalid key, like this, and for example you call this delete, we can see that we got an error here because delete is not assignable to type key of events. So if we change this to move, then it's absolutely fine because this is in the keys. So, but how can we use this? Well, the next thing we do is we go into our events, and what we do is we remove the static types here, and we create a mapped type. You can think about a map type like if you map over like your list or your array in JavaScript or TypeScript. So let's say we have our key in here, and we say this has to be in event key, and the value has to be a function. So now we can see we get a compile time error. We now have to change this to add and remove, and now we get an error at user actions because this move property is missing. So I have to add it like this, and now we can see that our code compiles. The problem here is still we don't have this on and the uppercase first letter. So as already mentioned, you can map over your keys. So what you can do is you can say as, you can use backticks to use so-called template literals, and you then can say, like you would do in TypeScript or JavaScript with backticks, you can then say, I want to have my key in there and want to prefix it with on. Now each of the keys here has to have the prefix on, like this. Now the last thing we need to do is capitalize the first letter of our key. How can we do this? Well, we can use the capitalize function from TypeScript. This is just a type which takes another type in there, and if we check what's the result of this, what this really does is it's a so-called intrinsic type. What this means is TypeScript does not show us how it does this stuff, but it's done by the TypeScript compiler, and it's done like under the hood because it's quite complicated and they don't want to like explain to us how this works. It's basically like a black box. So, but now we can see we can add here, we can switch this And now we have exactly the same as before, but now we have the advantage that if we change this move, for example, to line, we have to change this also, or otherwise we get a compile time error. So now we have created a map type where you have like your base and you can derive other types from it. So if you change like your events in one place, the other places also will no longer compile. So we now have seen here these template literals, right? So let me show you what you can do with these template literals. So let's say you want to build a chessboard. This is something we do on a daily basis. So we want to have each position of this chessboard. How would you create such a type? Well, you could say it's either A1 or it's A2 and so on. But you would have to do this 64 times. And you would always have to check if you have not forgotten one position. Now, you can do this better. You can use the template literals. Let's say we have our chess letter here. This is either A, or it's B, or it's C, and so on. And we say we have our chess number here. This is either 1 or 2 or 3, and so on. And now what we can do, we say we have our chessboard, we use backticks, and we say, okay, the first element is our chess letter, the second element is our chess number, like this. And if we now check the type, we can see it created for you each possible permutation of your chess letter and your chess number. And if you would change something in here, for example, add a D in here, we can see it now creates the other types as well. So this way you only have to like do this once and TypeScript will then do the heavy lifting for you. But of course, this is not something you do like on a daily basis. So let me show you something which you maybe use more. Let's say we have a type RGB CSS. Let's just say this is just a string. Now we have a valid RGB, which is of type RGB CSS, and we say, well, this is like a valid RGB string. Now even IntelliJ can recognize this is basically color black. But if I now say, okay, I remove one element, we get an error. We don't get an error, but we get an error basically from IntelliJ because it cannot recognize it. But we would also really like to have a compile time error from TypeScript. How can we do this? Well, we can use the backticks here for template literals. Say the prefix is RGB. Then in there, we only allow a number, followed by a number, followed by another one. And now we can see we get a compile time error for this invalid RGB because it does not satisfy this constraint you have given by using this template literal. So we can go even further. If we change this from 3 to 3a, we will get an error too, because this now is a string, but TypeScript recognizes that you only want numbers. So to make this work, you would have to change this to a string to make this work again. So, and by using map types and template literals, you can create really powerful types. So let's say you have your gap type, which is either margin or it's padding. And let's say you have your gap position, which is either left or right or top or bottom. Now we can say, okay, we have our gap CSS, which now has as a key the gap type, and as the value, we have our gap position. And what this creates, of course, is it's create our margin and padding left, right, and so on. So you have to do this only once. Now we can go further and say which size types do we want to allow. We say we have our size type, which is either pixel or, for example, percentage or rem. And then we can say we have our size CSS, which then has to have a prefix of a number, and it has to have a suffix of the size type. And now we can combine these two and create a mapped type from it. We can say we have our margin padding here, and we say the key has to be in gap CSS, and the value has to be size CSS. Now, what we can do here is we can add a question mark so that we don't have to provide every possible combination in our object. If we would remove this, and let me show you, I create now this margin object. And now I, for example, say I want to have padding right, for example, and I say 1 rem, then I get an error because the other elements are missing here. So if I add a question mark here, we can tell TypeScript I only want to provide certain elements of our object. So if I now, for example, remove one letter here, then it will no longer compile because it does not work with the types we've created. So this is about template literals. We will also use this later. So the next thing is about the never type. So many of you maybe have already seen it somewhere in code, but maybe have not really used it, because at the start I also was thinking like, well, how is this really useful? So what you can do is, before I will explain about the never type, we have to take a quick look into the conditional types. So let's say we have a type Boolean or else. And a conditional type always is a generic type, which takes as an input another type. What we then can do is we can, for example, say if t extends Boolean. So basically, if t is like a subtype of Boolean, if t is corresponds to this Boolean type, in this case we return Boolean. Otherwise, we return, let's say, string. Now let's test this. We can say Boolean or else, and let's say we pass in a number. And as you can see here, we can see that a string gets returned. Now, if I change this here to it being false, it returns a Boolean, because false is like a subtype of Boolean. If I say true, it also returns Boolean. So what you can do with this is like you put in it, it's like a normal function. You put in something and you get a new type out. And why is this important to know? Well, let's say we have a string here. And this string, of course, explicitly is a string, as we also could remove this here. But what happens if I change this to never? We get an error because we can see that string is not assignable to type never. Now, why is this? Well, never is like its own type. Now, all of you who have worked with Typescript, you know how to fix this. We just say as any. But in this case, it does not work because you can't even assign any to never. You can think about like never is its own type, and any is like on the top of this whole other chain of types, but never is like on its own. You can only assign something which is never itself to never. And maybe you think, well, how is this helpful? Well, let me show you. So let's say we have a function here. Let's call this function fail on empty string. We pass it in an input, which is a string, and we say, well, if the input, if the length is not given, we say throw new error, and we say here input is empty. Now, of course, when we call this with an empty string, we would get a runtime error. But because we are using Typescript right here, we would really like that this would not even compile, so that we get another like safety net prior to the runtime, so that we don't have to write like tests. So now what we could do here is we can create a type called noEmptyString. We pass it in a t, any type you'd like, and now we can say, well, if t extends an empty string, so we can say if t is basically exactly an empty string, we return never. Otherwise, we return t itself. Now, of course, nothing has changed, but now we can use this in our function. We pass in here another type here and say this t we use is a subtype of string. We only allow to pass in strings. And now instead of here just using a string, we say we use noEmptyString and pass in our type. And now what we can see is this code no longer compiles because the string is not assignable to never. Now, this maybe looks confusing at first. For me, it was too. But what does really happen here? So let's go through this. This is an empty string, right? This empty string is this t here, which we pass in. This is this one here. We pass this in our noEmptyString type function. This then, Typescript figures out, okay, this is an empty string, and it returns never. So basically what's here now is it's then here never instead of resolved, it's just never. And we have seen prior that you can't assign something which is not never to never. So this way we will get a compile time error. Now, if you don't get this at first, it's completely normal. For me, it was the same. But if you see this, like you get used to it. So, but maybe you don't really have to use this on a daily basis, and it's also maybe a little bit too, in quotes, complex to of code. But what I use on a daily basis is like the usage of never in exhaustive if-else statements or in switch cases. let's say we have a locations type here, and this is, let's say, either Zurich or it's Oslo, and now we have a function get country for location. We put in our location, and we want to return a country for each of these locations. Now, we can already see we get an error because we don't return a string, right? So what we do here is we say switch, and we can now say, okay, on the location, we say the case for Oslo here is we return Norway. But of course, we get still an error because TypeScript tells us, yeah, but you have not covered the Zurich branch. So if somebody passes in Zurich, we get an error. So of course, we can add this. And if we do this like this, we will no longer have an error. Now, this works fine, but let's think about if you call this function, let's say, from a JavaScript environment. If you're like a library author and, for example, you don't have the types, like you don't create like JS doc from it, and you can pass in anything you'd like. You can, for example, pass in Paris, and this would always look basically like this because in JavaScript you don't have these types. Now, in crucial parts of your application, you should always not only rely on the TypeScript types because, as already mentioned, they go away during compile time. So what you really should do is you should also have runtime checks. So what you can do is, of course, add a default case, say throw new error, and then tell, well, the location is not known. But now, if we go back to our code and say, okay, well, but we want to support Paris, right? So we go in there and we add Paris, like this. Now, if you're in TypeScript again, we can see, okay, we can pass in Paris here. But the problem is that now we have lost our compile time safety because it's that here TypeScript knows, okay, well, he has not covered it in these two branches, but it will go into the default one. So yeah, it will then throw an error. Maybe he wants that this happens. So the developer wants it. So, but of course we don't want to. And this is where we can use the never type. We just say we add a new variable here, and you can call this variable anything you'd like. I like to call this exhaustive, and the important part is we say this is of type never. Now what we can do is we then can say we want to assign the location to this variable, and now you can see we get an error because you can see type string is not assignable to type never, because TypeScript is extremely clever about this. It knows, okay, Zurich and Oslo is covered here, Paris is not. So there is a possibility that somebody passes in Paris. This will then go, location here will then be Paris, and we would then try to assign a string to never, which is not allowed. So we get an error. So this way we have a compile time and runtime safety, like both in place. And now if I add Paris here, of course, the error goes away because TypeScript now knows, okay, all the branches are covered, and this should never happen. But if it happens, for example, if you run it with as any, you still have your runtime safety. Now, some people said, well, when I gave this talk some time ago, they said, well, but now I have like this empty variable which is not used, and that maybe SonarQube or Linter doesn't like this. Exactly, and you can remove this, and you can use the satisfies keyword. So you can say this location here satisfies. It's really hard to type this. Satisfies the never type. And what this basically does, it tells the type, this location, has to satisfy the type never. And now nothing has changed, but if I, for example, remove Zurich here, we can see we get a compile time error because string does not satisfy the expected type. So this way you don't need like an additional variable, and you can do exactly the same with this with if else. You don't have to use switch case. You can use this with if else because TypeScript does exactly the same with the if else clauses as it would with the switch case here. So the next topic is like a preparation for the next thing we will do. So we will a little bit talk about infer. So infer is like this keyword who is used heavily by TypeScript itself, but it's rarely used by TypeScript developers which just use the language. So let's say we have a function. We have a really complex one. So because this function is so complex, we only want to get the return type from it. So we say return a plus b. And now in TypeScript, if you use type of, you really get the type of something. You don't just get, like in JavaScript, like it's a function, an object, a string. So what we can do is we can say type, add return, for example, and we say type of add. And what we now get here is we get like the whole type definition of our function. But as already mentioned, we only want the return type. And this is where we use the return type of TypeScript, and can now see we get the number. So if we change this to string, we get back a string. But how does this work? Well, let's create this ourselves. So we create a myReturn type, and we pass it in a t. And now we do basically the same. We create like a conditional type. We say, okay, if t extends a function type, so basically if t is a function type which takes any kind of arguments or no arguments at all, and it returns anything, in this case, to start with, we will say just return any. Otherwise, we return never, because we are not interested in anything which is not a type of a function. Now, if we change this here now to it being myReturn, we of course only get any, because we have not told TypeScript what we exactly want to return. We only told, yeah, return any. But this is where we can use the infer keyword. We can tell, okay, if this t here really is in such a shape, we can say, well, infer the type at this specific position. So we can say, retrieve the type which is exactly at this position and save it in a variable. I like to save it here in variable r, and then just return it. And we can see now we get the number back. So if I change this, for example, to Boolean, we get the Boolean back. So, and this is basically exactly how TypeScript does this. So infer can be used in really, really complex scenarios where you can even further make your types even more restrictive. And I will show you this at the end. You can also find an example on my GitHub, but I will show you this on my last slide. So as mentioned, this is a preparation for the next thing, recursion. So I know that like recursion is really can be scary, but the cool part about TypeScript is if you like go into an infinite loop, it will just stop. It will not like crash your machine or something like this. So let's say we have a type here, and let's call this nested promise. And let's say you have a promise inside a promise inside a promise, and let's say there is like gold in there. Now, we want to retrieve this nested type. We are not interested in these promises. We just want to have the type. Now, TypeScript knows that this happens quite often, that we want to unnest like promises. So what they offer is the awaited type, which basically recursively calls into the promise type and checks, okay, is it still a promise? Yeah, and as soon as it finds something which isn't, it will just return the type itself. But to show you how this works, we will now create such a type ourselves, but for nested arrays. So let's call this awaited arrays, and we pass it in a t. Now, what do we basically do here? We say, well, as long as t is an array, so as long as t is still an array type, please infer this inner type. So infer the generic type which is in there, and just call this our type again with this inner type. If it's not an array, if it's something else, we will just return the type itself. So let's test this. We have an array inside an array inside an array, and let's say there is even more gold in there. So what you now can see is if we check just the type here, we can see it's a nested array. To unwrap this, we now wrap it with our awaited array, and we can see we get the response back. And this is like the simple way of doing recursion in any language. Just you call into a function as soon as you find the element you want, you just return it. More complex it is when you like start building your own object and then like collect it and return it as soon as you have met a certain condition. What do I mean with this? So let's say we have a type here, and let's call this type RGB tuple. And a tuple with 3 elements. For every one of you who might not have worked with this, this is just like fixed length array. It's an array which it's a type which just has to have, in this case, 3 elements. Now, if we say we have our RGB tuple here, this is 1, 2, 3. This works fine. If I remove an element, I get an error. And now, but the problem here is, by the way, this is just has nothing to do now with this itself, but you can still do push or pop on it, even on a fixed length array on a tuple. To stop this from happening, you have to say that this is a read-only tuple, and this way you can no longer add or remove elements. But that's just as a quick side note. Now, the problem with this is, okay, this has now 3 elements, but you also can have like one with 4 elements because we have like the RGBA. And what you now would have to do is, okay, I would have to say, I take this read only, I wrap this, and I say this has either 3 elements or it has 4. So I have to say 3 or 4 elements like this. And now this would work. But the problem is, of course, this gets quite complicated. And let's say you have like a tuple with, if you want to have a tuple with 20 elements, then you would have to like count it yourself if it's really how many elements are already in there. And yeah, this is not really that nice. So what you could do instead is you could say, okay, I want to have a type tuple, but let's first check if there is something which already exists from Typescript. So wouldn't it be nice if there was like a tuple where you can pass in how many elements you'd like and the type of elements you want it to be? Well, sadly, this does not exist, but this is where we can use recursion and create this ourselves. So let's think about how you would do this in a normal language, like if you would use recursion. You would have like your function, which takes 3 arguments basically. The first one is the length you want your array to be. Second one, the types you want to have in. And the third one has to be like this accumulator, because you have to like add elements to this while you recursively call your function. And as soon as the length of this array is the same as the length you want, in this case 3, we want to stop. And this is exactly how we do this in types here. We say we have a tuple. The first one is a length. The second one, we call it type. And the third one is like an accumulator. And we tell the Typescript, listen, this accumulator, this has to be an array of type. So it only has, in our case here, it can only have numbers in it. Now, you can see here, we would always have to add an empty array to start with, but we don't want that, so we can say we initialize it with an empty array. So now, what we can do is, let's get started with the breakout condition. What we say is, okay, when the length extends our accumulated length. And by the way, when I first saw this, I was thinking like, how can a type have like a property? But Typescript sees, okay, this is an array type. So an array type always has to have like a length property, because Typescript also needs to track how many types are in this type array basically. So we can also access it. So we can say, okay, when the length extends the length we have, basically if we have reached our 3 elements, in this case, we just return our accumulated value. Otherwise, just call our function again with our length and our type. And now, how can we add an element to our type array? You can't use act.push, for example, because this has to be an immutable way. So we just, and this was also mind-blowing when I first saw it, you can create a new array and spread the existing types you have already collected into it, and then we just add a new one. And now we can see this no longer compiles, so let me show you what this now does. This creates now a type for you which has 3 elements in it. If I change this to 4, it creates for you a tuple with 4 elements. You can do this until 999, because the current Typescript version like has a hard stop for recursions for more than 999 recursions. So this is like your break, but if you use something like this with more than like 1,000 entries, then you should think if you're doing this right. So, but now what we still see is we are missing this read only here. So what we do is we say read only, and we wrap this, and now we get our read only one. But now this does not stop here, because we have seen we wanted maybe 3 or 4 elements. How can we do this? Really easy. We just say 3 or 4 elements. Because this now, Typescript is clever about this. It knows, okay, yeah, he wants like this 2 branches, either 3 or 4 elements, and it creates both. So I can now have my RGB tuple with 3 elements or with 4 elements. Works perfectly fine. I can also say I want to allow numbers or strings. Now I have a tuple which allows strings or numbers. Of course, you could also pass in like an object type, an interface. All works as expected. So before we now finish and go to the last topic, I'd like to show you something about branded types. And I think this is something which should really basically be used everywhere in the code. because let me show you what the problem is which this tries to solve. We have an email here. This is my email. Now, let's say you want to send an email. You have a send email function, you have an input, which is a string. Now, the problem is, if I use send email, I can pass in anything I'd like. I, of course, also can send email with my email, but the problem here is you have to sanitize this string somehow. Now, of course, you could do this in here in the send email, but you should like create a function is valid email. You pass in your input, and it returns a boolean, and we make this perfectly safe by saying it includes an @ sign. So this is perfectly safe. So now what you could do is, of course, we wrap now our is valid email, our send email with our is valid email. But as you can see already, yeah, but this does not really require you to use this is valid email, because you can still use it here without any restrictions. Now, wouldn't it be nice if there was a type, let's call this email, which would restrict your inputs to really being an email, to be like that this type was checked. So let's do baby steps here and start easy and say, okay, where do we want to only allow an email? We want to allow only an email at send email, and we want here, instead of returning a boolean, we want to have like a type guard. What is a type guard? Basically, it means that if this in here returns to true, we can narrow our type. What this means is we can say, well, okay, you passed in a string, but it's not only a string, it's also like something else. You can think of this like, let's say you want to pass in here an object which has a property a string. You could then check in here if this object also has a property b, and then you can say here, okay, this object you pass in, this has the property a, but it also has the property b, like it has more than you had expected. So, but how is this helpful? Well, we can now say input is email. Now we can say, okay, if this passes, then we say, okay, this input here is not only a string, but an email. But currently we can see nothing changed, because TypeScript tells you, yeah, well, but email is just an alias for string, is exactly the same. And here is where like the magic happens. So what you can do here is you can say, this is not just a string. This is a string and now you trick TypeScript and you say, this is a string and it's also an object, and you can pass in here any key you'd like. I like to have it as brand. I like to call this object property brand, and then as a value I like to call the type of this. But you can pass in anything you like here. It's only important that it's an object which has properties in there. And now we can see something interesting happen. Line 17 does no longer compile. Why is this? Let's check this out. Because string is not assignable to type brand email. Because TypeScript tells you, well, you passed in a string, but where is this object here? And so you can't even say, well, okay, this is an email, because TypeScript again tells you type string is not assignable to type brand email. So because of that, and why is this? And why does this work here? Why is there an arrow here? Because of this type guard. What does this type guard basically do? This type guard says, okay, there was a string passed in, but the developer knows better that this is also something else. It includes also like this object. Of course it does not, but as long as nobody like tells TypeScript this, it believes in us that this is really an email, that this is a string and an object. And the cool part about this is that because we cannot create such a composition in JavaScript or TypeScript, the only way to achieve that this is an email is by really calling it through such a type guard, or by using like an assert. You can also use like an assert that it would fail if it wasn't an email. And now you think, well, how is this really helpful? It's helpful because you don't have to wrap your primitives, and you can create like from your primitives all these different types. You could, for example, say, okay, I want to have a phone number. And somewhere in your code you check for your phone number, and everywhere else you have this type, you can be sure that this string is in the shape of a real phone number. Now, the cool part about this is also that this email here is not like a wrapped object. It's still a normal string. What does this mean? If I have a function which takes a string like this, I can just call trim with my email because it's still a normal string. It's not like a wrapped object which you always have to unwrap and like access its properties. Because as you can see here, if I check the email, it has all the properties from the string still, of course, because it is just a string. The only difference is in TypeScript you will have this brand property where you see which type it is. But of course in JavaScript you don't have this anymore because this is just like tricking TypeScript into doing like this branded type. But the cool part about this is that you can easily create for your primitives, also for example for numbers. You could say you will have like a type positive number, where you can check in your validate function if this is a positive number. If so, then you can see everywhere you use this positive number type, you can be sure that this really is a positive number. So this way you can have like your primitive types, and for example for each of your domain names, for example if you have like an ID or if you have something else specific to your domain, you can create the types like this and can be sure you can still pass it around like normal strings for functions which don't care about if it's an email or if it's a normal string. So what we now can do is, we have seen many different things, and now I will show you, if you put this all together, what you could like build with this. Not that you should, but what you could do is you could build like a calculator validator. This is also on my GitHub, you can check it out. It has everything in there we've talked about. It has map types in there, template literals, never type, infer, and recursion. The only thing it does not have is branded types. But what you can do here is, we can see here, we have here the validator, which takes an input, and as soon as this input is a valid arithmetic expression, it compiles fine. But this here are all invalid arithmetic expressions. For example, here it's a missing closing bracket, so it will no longer compile. If there are like the wrong amount of closing brackets, then it will also no longer work. And all this is done by only in types. So not that you should really use this like in something in production, but it really nicely shows what you can do. Also with much more heavy usage of like the infer keyword to do certain stuff. So I think now we are done with the presentation itself. We now will go into the questions. So let me just open. Yeah, I don't have internet. Let me connect to the internet. By the way, if you have seen this plugin with this question mark, this is called WIT for IntelliJ. This is a plugin I've created. You can download it, and basically what it does is you can just go in there, and everywhere you want, you can just add this. Go back to it. You can just add this question mark and this arrow to any point in your types, and it will resolve the types. Because sometimes the problem is that if I show you this for the recursion, we can see here if you hover over this in IntelliJ, there is only this empty read-only array. It's not like clever enough to do this, so I like had to build something to really show this. So, but let's go to the Q&A and let's check if there are any questions. It does not look like there are any. Maybe. Cool. Yeah, it's fine if there are no questions. By the way, has somebody asked a question and it's not on here? Okay, yeah, back then. Maybe you go to the questions. Yeah, if there are any questions later, I know it's really overwhelming. I know it. It's really much information in short amounts of time. I know I speak a little bit fast. I know that, but I have to like pack it in all in this 40 minutes. So if you have any questions later, just send me a request on LinkedIn. Yeah.
Hi.
Hi.
Thanks for the presentation, first of all. And I have a question about the example you showed about the RGB types, the literal types.
Yeah.
And there was no check for the range. So we can achieve this with brand types, or there is any other solution?
Yeah, the problem is with currently there is a solution, but it can be done by restricting it to like from 1 to 255. But the problem is this also involves heavy recursion, and it would create so many different types because it would like create the types for if it's 1 and the other one is also 1. So this would like blow the TypeScript compiler. So this could not really be done by using like these template literals. This is not possible currently.
And with the brand types, we cannot create a brand types which says that is it valid if it's between.
Of course,
that's
no.
The same.
That's you could do this absolutely. That's 100%. You can create this here. You can of course do. It will then not throw an error, and will not show you why it is that it does not work. But you can do this absolutely. You could create like an RGB type, which then checks if everything is correct, and you can only pass in something if it has passed this brand. Absolutely, this works. This works perfectly.
Thank you.
Yeah, there was some other question, I think. Or, yeah. Yeah. Sorry.
Okay. Thank you for the speech, by the way. Just pretend we have an array of lambda function that converts from A to B, from B to C, from C to D. Can I use recursion to define that the first element in the recurrent array is concatenated somehow to the second, to the third, and the last one has to produce the output, the desired output?
You can do this because this infer one, the infer one here, you can see I inferred here just a return type, but you could also use it like to infer this inner types here. So what you could do is like you could combine recursion with this infer to say, okay, the thing that you just passed the second one has to be the input from the this would be really nice actually, but I would have to think about how this would really work. But you could do this with recursion and with infer, and if you'd like to do this, just like send me an email and I will look into it, or we can look to it together. Yeah, there was no question over there. We'll send you there.
Thank you for everything. I'm quite new to TypeScript, but I have maybe a simple question that is, now we have typing, for instance, email by writing directly, but what if I have no clue of what email is? For instance, if I read from a GET REST API or it is fetched from a DB, and can still types help me in a way?
Yeah, exactly. This is always. I think I know what you mean. So it's like what you think is like you get like the string from the API, and you have to like know that this is a valid email or not. So what I would do is, if you retrieve this as a string, you could then use something, for example, called an assertion. This one is just like this is a type bar basically, but you can also say asserts. I will save asserts email input is email, and you could then say, well, if the input here, if this input, if the input, if not the input includes that, then we throw an error. And the cool part about this is that after this function call, everything, the TypeScript compiler knows that everything after this call is sure that this email is a valid email. So you could just say in your getter, really nice question. So after this, you could, for example, in your response, you just say asserts this is an email, and after this, it's like sure that it has to be an email, or it will throw an error. Thank you. All right, I think we have to stop because the next ones will come in. If there are any questions, go to LinkedIn or send me one on Twitter or a mail. Yeah, thank you.